Hey everyone, my name is Victoria. I'm the senior security architect in Microsoft, based in Norway, working with the security, everything around the cloud security, DevSecOps, development security, and so on. And I'm so excited to have today with me Rob, who is the DevOps engineer from the Netherlands, and he's so passionate about the GitHub Actions, but actually he's using that from the day zero. And as well as me, he's a huge fan of the security. Hey, Rob, how's it going?
Yeah, good afternoon over here in my time zone. Everything is going great.
Yeah, and how's the weather in the Netherlands?
Yeah, we had some sun finally picking up earlier today. It's still shining, so
That's good.
it's a bit all over the place, but at least it's dry, so that works.
Okay, then you can't complain as me. We have the rain, still no snow. But I was wondering, you mentioned that you are the DevOps engineer. So how did you end up being as a DevOps engineer?
I'm thinking about that. I'm actually a DevOps consultant, so I help other people to get into the DevOps mindset. I don't like the DevOps annotation of it being an engineer for specifically DevOps. I'm mostly an engineer with a DevOps mindset, of course, and that's a huge difference. But I've been doing development work and operations work for such a long time. And then when we really started calling it DevOps, that was something that fitted me because it has that passion of looking at both sides. Of course, we're not tossing anything over the firewall anymore, saying, "Hey, it's now your problem." It's really that DevOps mindset saying, "We need to do this together. I'm responsible for keeping it in the air as well." So I grew into it, basically.
So what do you find the most challenging in the DevOps journey, when you work across the customers? What is
I
most
work with a lot of
challenging?
enterprise customers still. So most of the enterprises still do have a wall between dev and ops. It's still like they're still reinventing the wheel each time. And that's still an occurring thing. So getting that mindset shift over to we're not two different teams, we're handling this together and we want to deliver some value to our customers. And that's often still something that we need to tell them.
And when you try to squeeze in the security guys there, it
And
becomes more
everything falls
hectic, right?
apart. Yeah.
Yeah, and I think this is what you want to share today as well, right? Speak about the DevOps from the security perspective, and is that talk more oriented for the developers or to these old grumpy security guys?
Well, both of them. I usually try to wake up the developers, be saying, hey, you are creating these pipelines, for example, and you need to make sure that they are secure. And then we'll go over the security aspects of the things you need to talk about, need to think about as well. And usually that at least scares people awake, making sure that hey, I shouldn't be doing this. For example, I'm not such a fan of the defaults using GitHub Actions because the defaults are already inherently insecure. And this used to be the initial guidance that GitHub gave everybody when we started with Actions. Use these best practices to make everything more secure. All of a sudden, that's now gone from each and every introduction or demo that people give. And I've always been I always had that mindset. These things are running on an agent, on a runner somewhere behind your corporate firewall. And that's, of course, scary. We're now pulling in arbitrary code from the internet. Um, yeah, with that security mindset at the back of my head, that always then freaks me out when I get it to a customer. And they say, oh, we want to move over to GitHub Actions. The first thing I always ask is, do you have read about security implications of that? And usually, of course, nobody looks at that. And that's why we have a job right now, making sure that everybody is at least aware of the security implications before they get started and not somewhere learn about that after the fact.
It sounds like you're giving the spoilers of your talk, right? Right
Oh,
now.
no,
No?
it's the interesting part still to come, so that helps.
And speaking about that interesting part, would you mind to share it and let's deep dive into your presentation and
Of
share
course.
with us all the best practices in terms of the making GitHub Action secure?
Yes, let's get started.
Let's get started.
All right, I can see my slides as well, so we'll start. Okay. Good afternoon, good day wherever you are. As I said, my name is Rob, and I'm a DevOps consultant at Experts. We're based in the Netherlands. You can see my blog in here if you want to follow along and learn some more information. At the lower left-hand side, you see my GitHub handle. So if you have any questions, please share them in the chat or either afterwards. Connect with me. I'm always happy to dive deeper into these topics, and usually I learn a lot from the questions that we get. So please ask your questions in chat. We will moderate them and we'll try to answer them after the session. Let's dive into the whole security aspect. But just to make sure that we're all on the same level, we need to make sure that we have the same vocabulary. Because it's not only about GitHub Actions, we also need to talk about GitHub workflows. So let me introduce that for the people who haven't seen that before. The workflows are text-based files, and they are stored within your repository as well. They are they provide the execution environment on an agent that executes your workflow file and then execute one or more actions. The workflow can be triggered by lots of events. We have webhook events, you can start them manually, and currently there are over 27 events that you can use to trigger a workflow to get running. In this case, for example, pushing code into GitHub when somebody runs git push over to the remote on GitHub side, when somebody creates a comment on a pull request or tries to create an issue. All those things can start a workflow file. And then the actions are the steps in the workflows, the things that are actually doing the work. An action can be as simple as a basic shell script, echoing out some script or some variables that you have, but you can, of course, build on top of that. You can create your own actions. You can use JavaScript for that, or even host them, running them from a Docker container. But you can also use the marketplace to find out about existing ones. Because, of course, the ideas behind GitHub are we live and learn from the community. So we have a marketplace that people from the community can share and contribute their actions to. Last time I checked, we have over 10,500 actions available on the marketplace. So there's a good chance somebody already created something for the issue that you have at hand, the task that you want to do. So we don't have to reinvent the wheel. You can go to the marketplace, search for an action. I want to add a comment to an issue, for example, with a specific text, and there's probably somebody who has already created that for you. Now let's look at the workflow file itself. As I said, it's a text-based file, and it needs to be stored inside this location. This needs to be .github/workflows. That needs to be plural. If you don't add a plural, then you will be scratching your head for 15 minutes, asking yourself why it isn't working. You can ask me afterwards how I know, of course. This has actually happened to me. It's a YAML file, so that means that indentation here matters. And we can see that we have a trigger in here. This is the trigger that we're subscribing to, telling GitHub that when somebody pushes code over to this repository, this workflow will start for us. Then we have a job in here. Its ID here is build and deploy. And we target a specific environment label with this. So we're targeting production in this case. Then we have a set of steps. That's an array of steps that will run sequentially. In this case, this is the most used step that we have in the marketplace, that is actually checking out your source code. Most of the people still want to build CI/CD systems with it. And for that, you need your source code on the runner that is executing your workflow file. Then we have an action that installs more software onto the runner environment. In this case, we're setting up .NET Core with a very specific version because our application apparently needs that. And last, we have a script here that's just a shell script, and it calls .NET Build, trying to build our repository that we have. Now, and with that out of the way, let's get started with looking into the security aspects of using GitHub Actions. I'll go over the repository security. We'll dive deeper into the runners and what you need to know about that. I'll show you the actions and what you can learn from them yourself. Then I've got a good way of best practices by forking actions. And then we need to make sure that we keep everything up to date as well. Let's start with the repository security. First, we need to look into who has access to your code, because that might be a possible attack factor when you use GitHub Actions. As you might know, you can set access levels at 3 different levels in your GitHub environment. You can do that on the repository level. That's the lowest level, where you can give somebody specific access to only that repository. You can do that on the organization level and give somebody access to all the repositories in the organization. And you can do the same on the enterprise level, where you give somebody access to all the organizations inside of your enterprise. We need to think about what permission levels do the users have. And it, of course, goes from the top, that somebody has no access, to the bottom, that somebody has full administrative access on, for example, a repository. The no access one is interesting here, because that's a default access when you're not logged into github.com, for example. But if you go and you authenticate against github.com, so you're a logged in user, you can go to any public repository and you will have read-only access to everything inside the repository. So that means that you can see the source code, you can see the workflows, But you can also read the action logs from the executions of the workflows. So be very aware that when you have a public repository, everything in the logs is included for an authenticated user as well. On top of that, we have, of course, triage, where you can manage issues and manage pull requests. That's very helpful for the community. Then you can give somebody write access. That's, of course, self-explanatory. And then we can give somebody maintenance access. And that means that they don't have access to anything sensitive, like, for example, your security alerts. And they cannot do anything destructive inside the repository, like, for example, remove the repository or rename it. They can also not delete releases, for example, or delete packages that you have published. And then, of course, administrative access has the full access to everything inside the repository. If you want to configure that or figure out who has access to what, you can go to an organization. In this case, I'm using the Global DevOps Bootcamp organization that I'm part of. You can go to the People tab and find all the people and all the teams that are in there and that have access to this specific organization. And you can see which levels that they have. If you want to know this on the repository level, you can go to the repository, and then you can find the same information on your insights and then on the people. You can even find out for a specific user what access that the user has. So if you go to the user profile, in this case, this is my GitHub handle, you can see that I'm an owner of this organization. You can see that I have access to 81 repositories and 2 teams in here. And you can even see for all the repositories which specific access level that I have inside of that repository. Because I might have a read access, for example, on the organization level, and full administrative access on the repository level. So now you at least know where to look and how you can find out what access levels are being set at a specific level, either organization and the enterprise level or at the lowest level, the repository. All right, so now you know where you need to look for who has access to your code, because they might be able to change code and then inject an attack vector for that. Let's look into the workflow secrets. As you might know, you can create repository secrets and even organization level secrets, and you can inject them into your workflow file. We do that by setting up, for example, in this case, an action, and we say we have a width parameter there, and we send in a publish profile. In this case, it comes from the secret store, and that is then now, in this case, a publish profile to push something into an Azure environment, for example. That publish profile will be stored together with your repository. The nice thing of workflow secrets at GitHub side is that they're actually secret. They're encrypted client side before ever sent over to GitHub. Your user interface, when you use the UI, the web UI already does that for you. There's a transparently created public key for that, and it is only used for encrypting, and you cannot decrypt those keys with that. Different CI/CD systems have, for example, a different way of working. We can actually read back the secrets in the UI. So they are decrypting everything client-side, for example. So this is a more secure option. And when you want to use the REST API, you need to encrypt the secret as well. You need to send it over fully encrypted so it doesn't go unencrypted over the wire. Do be aware, I said, that the secrets are stored with your repository, but when somebody creates a fork, then it's only the contents of the repository itself and not all the metadata, like, for example, secrets. So when somebody forks over your repository, your secrets are still safe because they aren't transferred over to the fork. Then we need to be aware of who has access to your secrets. And if you want to create, update, or delete them on the repository level, you need to have full administrative access on the repository itself. If you want to do that at the organization level, then you need to have admin access to the entire organization. So for creating secrets, that's a pretty big permissive set of rights that you need to have. The nice thing of adding them at the organization level is that you get access policies on top of that. Where you can say, hey, this secret can only be used in these 5 specific repositories, or by all my private repositories, for example. You have that policy where you can mix and match and fine-tune it to your needs. For example, create an organization-level secret for a specific team, and then give all the repositories for that team access onto that secret. As I said, those secrets are encrypted, but only until you start using them. GitHub, of course, has the private decryption key, which they can use to decrypt the value. And when a runner picks up your workflow file, it will need that decrypted value and then inject them into the workflow. It will either try to inject it as an environment variable or as direct input into your shell scripts. GitHub tries to redact those secrets in the logs as much as they can. So if your action says echo this value out into the log, they try to figure it out. They're using a regular expression for that. But that's also something that you very much need to be aware of. Because if you use structured data like JSON, XML, or even YAML in your values, then it will be very hard to redact into the logs. Combine that with what I said, that everybody who has read-only access to your repository, so any authenticated user against github.com has read-only access to your public repository. This is something that you very much need to be aware of. It might be a huge attack vector. Because the action might do anything with them. You might have an action that is somehow mistreated. Somebody injects some malicious code in there and now starts to exfiltrate all your secrets over to the third-party API that they have. They might try to spool it out into the action logs, as I said. And you might think, well, you just said they would be redacted in the logs. Well, here's an example where we echo out a demo log value from the secret store. And then in the second line, line 14 in this case, I'm doing something specific. I'm adding a space after each character in the secret. And what happens then is that the regular expression tries to run, tries to obfuscate this value. And of course, you can see the results. On line 6, we see this result of the first attempt, where it's actually being obfuscated. But the second line just shows everything in plain text. It used to be like this had to work. We could prove that this was available because we were base 64 encrypting the value and then spooling that out into the log what wasn't picked up. But even by something simple like adding spaces, my value is now visible in plain text inside of my logs. And if this is a public repository, then anybody who has read access, so is already authenticated against github.com, can see these values in my logs. So be very aware of what you use your secrets for. Right, next up, let's look into your own code that is in the repository. I already said it, that might be an attack factor into your workflow files as well. And with your code, I really mean anything stored inside your repository. Whether it's workflow files, shell scripts that you use, you might even use those shell scripts in your workflow files. Your own code might be an attack vector to trying to break out of your pipeline, but also all the dependencies that we have. We're not reinventing the wheel, we build on the top of shoulders of giants always, and we use a lot of open source packages in our tooling. Whether it's third-party packages like something from NPM or NuGet or PyPy, or a container image that could have multiple layers in there, even a vulnerable base image could be in there. So we need to check your own code and all the dependencies that we have as well. So at least start by injecting some static code analysis. Make sure that you don't have an attack vector in your code because your code might be being executed while you run a build, for example. You have something custom in there, and that might be triggered when you run a .NET build, for example, and all of a sudden it might try to do something weird inside of your workflow file. Also be aware of all those third-party dependencies that you're pulling in. Depending on what research you try to follow, at least 70% of the code that you're running in production hasn't been created by your company. We're all building on those dependencies, and there are even some people who say that 99% of your code hasn't been created by you. All of that might have known vulnerabilities, so at least start scanning for those known vulnerabilities. And one good way to try to remediate that is at least keep your dependencies up to date with a good security process. When somebody creates a new security update, then pull that update in, review it, of course, before you start using it. And of course, you can give an entire session on how to scan up all your dependencies. So that's a bit out of scope for this session. But be aware that those are all now attack vectors of your workflows. I've got some examples later on that will show you this. So if we look at your own code in the repository, we need to figure out who has made changes to what, and at least have an audit trail there that you can follow to see what happens and who created the commit, for example. Well, for the commits itself, it's rather straightforward. You can go to the Git commit history, and all the history is there. So everybody who has at least a linear history can see that. And hopefully you're only giving your admins history rewrite privileges. But everything around your code is also available inside of GitHub. You can find that in the audit log, and it's a very powerful feature that we have available. For example, we can check who made changes, and I'm doing this at the organization level again, at the Global DevOps Bootcamp organization that I'm part of. If you go to settings on the organization level, you can find the audit log, and you can see the last 90 days of events that are stored in here. And really, anything around your repository will be stored in here. When somebody creates a personal access token with a specific scope, that will be stored inside of the audit log. When somebody enables a wiki feature on the repository, that is an action, and it is stored inside of the audit log. So there's lots of information here, and you can even spool it out into your own business intelligence system, for example, or external reporting tool, so that the people who need it, for example, auditors, can have access to that. So it's very powerful to know that it's there, but it's only storing the last 90 days of your data. So if you want to have more, you need to export it and manage it somewhere else. I also have that at the account level. So if you have a public account, you can see that I here go to my settings for my own account. And then you can go to the security log. We have the exact same information, but this is, of course, for all the stuff inside of my repository. All right, that concludes the part for our repository and what is in there that you need to be aware of. Let's continue with the runners and the security implications of using them. As you might know, we have two different sets of runners. The runners are the runtime environment that our workflows will be running on, and the runner will execute the actions for us. We have two types of them. We have a self-hosted runner where you install everything yourself, and we have a GitHub hosted runner. And they have some differences that you need to be aware of. For the self-hosted runners, of course, that means that you are hosting them yourself. So you install them on your own virtual machine, maybe in the cloud, maybe on-premise. But it also means that the operating system for those runners and all the updates for all the tools that you want to install on those runners are now your responsibility. So you need to keep everything up to date and secure and under control. It does give you the opportunity to use a very specific setup for your environment. So you can, for example, create a runner that has a GPU enabled. The GitHub hosted runners currently cannot do that. You can install a runner on a Raspberry Pi if you want to. So you can get very specific with the hardware setup, but you can also now install your custom software on top of that. For example, some third-party suite that you need to incorporate that has a specific set of license keys. You can now install that on your own self-hosted runner and use them from that. Since you're already hosting them yourself, you're paying for the compute yourself, and that means that you don't have any usage limits on those runners. Whereas if you go over to the GitHub hosted runners, you have a set of minutes that you can use for every month or so. And if you go over that 3 minutes that you have, then you start paying for the minute that you are claiming that workflow run. It's also shifting over the responsibility of making sure that the OS is up to date and all the tools that are installed are up to date and are using the latest security patches. It shifts that over to GitHub's responsibility. So that's, of course, why you're paying. They are setting up the compute and they are doing the maintenance for you. Right, because we need to think about the whole security setup. And especially if you host your runners yourself, then you need to think of all the things that the runner has access to. These things might be running behind your corporate firewall or maybe in a specific cloud setup, and you want to do something within your network, for example. That will mean that the runner and the user that the runner is running under can traverse your network, for example. You may be doing something with an internal database, and now that connection can be made. So be very aware of the rights that you give the user that you install the runner with. Similar for sharing state between runs. The first run might pull down some packages, store it in a cache, and then a secondary run might be picking up those packages. So be very aware of what access rights you give to the runner or the user that you install your runner with. And as a best practice, I always recommend run that action inside of a container, give it another networking boundary, and make it hard to escape from that boundary. You can do it at the step level, where you can even say this step uses a Docker container. And that means that that entire container will run, will do something for you, and afterwards it will be cleaned up. Even better, you can do that for the entire job. So at the job level, you can say this one runs in a container. In this case, I'm using the OpenJDK version here. And all the steps that we have will now run inside of the container. This also saves me a headache from installing software inside of my runner environment, because I'm pulling down a container image that has all that software installed. And this, of course, prevents from, hey, it works on runner A, but it doesn't run on runner B because we have done some maintenance mess there, and that you don't have the right version or the right update installed on one of them. So this makes your life a bit easier as well, and in my opinion, it's more secure as well. And as a really important best practice, never, ever, doesn't matter what you do, never use a self-hosted runner for a public repository. Because we've seen those examples where you have your repository, they're open source, they're public, so somebody might create a new fork from them. They can already see all the code in there, they can see the action logs inside of your environment, and they figure out that they have an entry path into your workflow file. They add some malicious code in there, and now create a pull request back into your repository. And you are now executing that workflow file behind your networking setup, maybe even on-prem. That means that you're basically running arbitrary code from the internet. So that's hugely scary. So as a best practice, don't use that. Have a way to mitigate against that. For example, run them on a GitHub hosted runner. Have to shift that security responsibility over to them. Then you only need to figure out what the workflow is doing there, but at least it cannot traverse your network, for example. And there are different ways for that as well. I think I've got some examples later on that as well. I already mentioned that persisting data between runs might be an issue. And I gave the example of the first run that downloads your dependencies, builds your code, and somewhere along the line, might be your own software that has a vulnerability, might be a third-party package that you're using. Somewhere along the line, we override the dependency cache or a container image. Then the second run comes in and say, hey, I need this dependency. And your package manager that is handling that says, well, here you go. I've already got it on disk. Feel free to use this. Now builds that code, and your malicious dependency is now included in your build artifacts. And you then distribute it into all your customers, for example. And you might think, well, Rob, that sounds a little bit far-fetched, but this is exactly what happened with the SolarWinds attack that we've seen last December. I could really recommend going to this link. It's case sensitive, so be aware of the capital S, and read more on the SolarWinds attacks that we've seen, also called SolariGate. It's a very interesting read to see what is in there. And since you get access to the slides later on, you can go to the links at your own leisure then. It's a very interesting read, and you can learn lots of it from it. So it's not something that might happen. This is already being taken advantage of in the wild. So as a best practice, don't share your runners. Don't share the runners between repositories. Always have something set up to have that safety that one repository cannot, for example, override your cache, and that the secondary repository then has a run that will pick it up. Don't install multiple runners on the same machine. We used to do that in the past, but that is now an attack vector, so you shouldn't do that anymore. And I've already mentioned some of the risks. They might install a malicious program, and hopefully it's just something benevolent like a Bitcoin miner. But it also might be the starting point of a ransomware attack. They could try to escape your runner sandbox and do really weird things inside of your network because you have exposed your network environment because you need to talk to the database during your integration test, for example. Even persisting unwanted and dangerous data is part of the whole attack vector here. Right, that at least we've mentioned the information that you need to know of the runners and their security aspects. Now let's dive into the actions themselves. As you know, we have a marketplace for that. You can go to the marketplace, click on the use latest version when you find something that will work for you. In this case, we have an action that runs on AWS and it can target EKS. And if you click on use latest version, it will give you a nice pop-up that says, hey, copy and paste this code over into your workflow file and you're ready to go. Well, the nice thing of actions and how they've been engineered is that you can copy over the uses part, paste it behind github.com, and now you have the direct link to the URL to the repository on github.com. And since all the actions stored, published to the marketplace have to be open source, you can review what the action is doing. Because otherwise, you're just pulling in arbitrary code from the internet. And if you do that for an enterprise, and maybe even on your corporate firewall or behind your corporate firewall, that might be very scary. But that's why I'm trying to get over that message that you need to look into what the action is doing for you. So if you pick up anything from the session, at least start there, dive into the action source code before you start using it. We already mentioned some of the attack vectors. I mentioned the data integrity breaches that you get when somebody overrides your dependency cache. I already mentioned data theft, where somebody exfiltrates your data, for example. It could be a repository, it could be the SSH keys that the runner has access to. It might be the certificates that are installed on disk that it might be exfiltrated. But one possible attack vector is also availability. What if you have a public repository and that deploys your webshop, for example, into production? And now people can see the logs of those actions. They can see your workflow file. They might figure out an attack vector. And right at the moment that they start targeting that attack vector, they somehow break your workflow pipeline. And since we are now so dependent on our pipelines to deploy to production, all of a sudden, your developers cannot push to production anymore. Do you have a mitigation strategy against that? Do you have a four eyes principle that they now need to follow and figure out in the middle of the night how to still deploy into production and prevent things from happening there? So your actions that you use might be a huge attack vector for you. So what can we try to do to prevent this from happening? Well, as there's anything you're taking away from this session, view the action source code, figure out what it is doing, and then make a decision if you want to take on the risk of using that action in production. Check all the dependencies, check all the container images that are being used. It's very important that you start doing that. Because it might be as simple as somebody pulls in a specific repository. As I said, the users part is part of the public repository, which also means that as long as it's a public repository, any repository that has an action.yaml inside of it can be used inside your workflow. It doesn't even need to be published into the marketplace. Even worse, the runner, when it executes your actions, doesn't even check if that action has been published on the marketplace. There's no checkmark policy that says only use actions from the marketplace. There's no check on GitHub side that says this action is safe to use. This is, of course, an example of a totally non-harmful you must use it action that only wants to have access to your secret value. Well, guess where I got the inspiration of adding spaces after each character? And this is a publicly available repository. It hasn't been published on the marketplace because it is, of course, just an example. But it is a possible attack vector into your repository. And if one of your engineers finds this and says, well, I want to include this inside of my workflow, they are free to do so, unless you start protecting yourself against this. One of the measures that comes up, then of course, I already gave it away, and not only use actions from the marketplace. There's no real verification process on top of this. You do see a bar at the repository that says this one has been published to the marketplace, and that's it. You might say, we set up a policy that says we can only use actions from verified creators. You can go to the marketplace and you can see the badge everywhere that says this one has been checked, and this one is a verified creator. Well, the hard part is that there's no real information for the user of GitHub Actions, what it entails to become a verified creator. I've been searching long and hard for this. Even the link on Learn More About Verified Actions doesn't really say what the process is to become a verified creator. It took me quite a while to figure out what it actually means. And there's some documentation if you want to become a verified creator in the docs from github.com. And that means that the verified creator has gone through a verification process. The steps in there are that you need to have a GitHub profile that is actually there and it is accurate, because normally you can start a GitHub profile with just a username and a password, and then you're good to go. So they really want to have your email address, for example, and other information. It says that the organization that is publishing the actions has at least two-factor authentication set up. So not everybody can just arbitrarily push code into the repository and do something there. We need to have two-factor authentication on top of the users that are pushing code in there. And it says that you have set up domain verification. If you want to know more, go to this short link and learn more about that information. It's not that much more there than here, but there's some quite interesting things to add. But overall, this is the process of becoming a verified creator. And these steps I can do myself. I can create, get a DNS account somewhere, add a text record, set up two-factor authentication on my temporary email account, add that to my profile. And now with malicious intent, I have still become a verified creator. So I still don't like that option of limiting the actions in your organization to only be used from verified creators. That's not good enough in my opinion. Well, what more can you do? Well, you could say we have a permission set up on the repository in the organization level where you say, hey, we disable actions completely. I now got so scared that I need to figure out how to do this first. Well, of course, that might be an option. But of course, you can have a better option, and that is start verify the actions that you want to allow inside your organization. You can do this at the repository level, the organization level, and you can say, I only want to allow specific actions. You could say, I allow actions from GitHub, for example. Those are stored in the /actions organization or the /GitHub organization. And you might be safe. You might be okay with the risk that you're taking when you say these are safe to use. I'm not so fond of that because there are a lot of actions on GitHub's organization now that have been marked as deprecated, that has a small snippet at the bottom that says this one has been marked deprecated, and you can use this open source version because the community has taken over the maintenance for it. And since they are now marked as archived, they cannot update them, they cannot set up new security features on top of them or patch things. So this isn't good enough for me as well. I already explained why I don't like the allow marketplace action setup. The best option is to say only allow specific actions. And you can go wild with this. You can mention specific actions in here, specific versions of that actions. And you can, in this case, I'm using my actions org. That's my user handle -actions. And I say all the actions that I've stored inside of that organization are for me free, for me good enough. You can use those. This is usually the guidance that I give my customers. This is a starting point from taking control, making sure that you have all the actions stored inside your own organization, take control over their security and maintenance setup. And this is a good starting point. Because if somebody now creates an action that doesn't comply to this filtering option, they will get a pop-up. Even before the workflow is being executed, the runner downloads the workflow first, validates it against the list of allowed actions. And if it doesn't match, you get a nice warning. The workflow file will not be executed. There will be no further data downloaded onto the runner. It will halt immediately. So this is a good starting point. Well, what more can you do? Well, we can start using version pinning. That is now the common guidance from GitHub as well. The user interface doesn't even let you store a workflow file anymore without using version pinning. This is following semantic versioning. So when you say, I want to allow version 1, then all the updates coming after version 1.0.1 will be pulled in as well. So if you want to be specific, you say, I want to allow version 1.01. Well, the hard part is that these versions come from Git releases. And Git releases are created by using Git tags. And guess what happens with Git tags? You can reuse a Git tag. So you could say, hey, I've verified the code that is inside of this repository. I've checked version 1.01, and I'm okay with using that inside my organization. And after a while, the publisher of the action might say, well, I need to add something there. Hopefully it's just something benevolent. They add that and then reuse that tag with the same code and publish the same version back to the marketplace. So now you're pulling in an update that you even haven't reviewed. You don't get a notification for it. Nothing happens. So now we're still pulling in arbitrary code changes from the internet. So of course, that's not good enough for me. The best practice here, and that's sort of missing in all the demonstrations right now, is that you need to pin the commit SHA. The commit SHA is immutable. It comes from committing something over to a Git repo. You can find that SHA in the UI as well. Search for it, and if somebody now adds code to the repository, it will have a different SHA. And that SHA, it cannot be changed. So if you use a specific SHA hash in your workflow file, then it will always be downloading that specific version of the action source code that you have reviewed. So this is the most safest way. As I said, as a recommendation, as a best practice, limit it to either local actions or only select actions in a specific organization, and then fork over all the action repositories. All the action repositories are public repositories, so you have the opportunity to fork them over to an organization under your control. If you then say only allow local actions or select actions in your organization, do be aware that this is now a boundary for your DevOps teams, because they cannot just start using new actions from the marketplace. So do set up a test organization where they can test freely without using production source code, for example. Because we need to think about all the attack vectors against our workflows again. And there are two ones that I want to address. The forks of the public repositories that I already mentioned a bit, and the common fields that can be used inside your workflow files. Let's start with the first one. This is an interesting one to know. We have 3 different events regarding forks that might be triggering your workflow file to execute. We have push, pull request, and we have a newer one that's pull request target. The first 2 are safe to use. It runs on the merge commit and it has read-only access if it comes from a fork. So it cannot do anything with your code inside your repository. It cannot write back into your issues, for example. It doesn't even have access to all the secrets that your workflow could use. For the pull request target, this is the newer one, and this has a very high risk. This used to be the default for pull request, but they decided to make that more secure. The pull request target trigger will run on the target, and it has read and write access to anything inside your repository that you've given your workflow file access to. It can even access your secrets. So it might even, if you have something in there that deploys to a Q&A environment, for example, when you use pull request target as a trigger, that will have access to that. So be very aware of what you do. Don't check out code with pull request target. Don't build it even. Don't run the code from a pull request coming from a public fork without adding additional validation steps. You can, for example, say my first workflow that will be triggered will be running on the pull request. That will validate that you're not pushing any weird changes in there, that you aren't altering, for example, your workflow files or adding dependencies to your setup. And if that's okay, then you can still have somebody manually validating that it has been reported okay. And then, for example, label the pull request, because only a maintainer of the repository can set up labels or add labels to a pull request. Then start a secondary workflow that has pull request target trigger, and then it can do more work. So be very aware of these differences. If you want to know more, then I can recommend going to the short link. It has lots of information available, from even capture the flag events that GitHub has hosted, where they invite the community over and say, please hack our workflow. This is a repository that we set up. We want to learn on how this works. And we've seen really cool examples of people misusing fields that I'll show you next inside of the workflow file to do weird things. But first, let's talk about those pull requests again. The pull request might use a secret called GitHub token. That's a short-lived token that is always created when the workflow starts, and it has a specific set of rights. And by default, it has read and write permissions to your entire repository. So it can read and write issues. It can create comments on pull requests. It can even write back to your repository. This is now the default, and I don't agree with that as much. It should be, it only has read permission on it. Luckily, that's already the case when you use a pull request coming from a public fork. That's now the default, because we never ever trust forks anymore. You should have a verification process for that before. So when it comes from a fork, then the GitHub token only has read permission to the repository. But you can even dial that even down more. You can go into your workflow file and say this workflow needs these permissions on the GitHub token. So in this case, we only want to have read access to the contents of the repository. So we cannot write any commits back to the repository. And we also need write access to the pull request because we want to annotate them with a comment, for example, if this workflow has been completed. And then when you use the repository token, it will only have access to the scopes that you give it in the permissions. You can combine that, for example, with code owners that says only my senior DevOps colleagues can authorize changes to the workflow file, for example. Now you have some layers of protection of somebody changing these permissions inside of your workflow file. Be aware that you can set those permissions at either the entire workflow level or at the job level, so you can mix and match whatever your needs are. Now let's dive into those common fields. All these fields can be used by your workflow file and might be misused doing some work on side of the execution environment. Even the branch name might be misused to try to break out of the sandbox and do weird things. As an example, I here have a shell command that we run, and we're injecting here a title coming from an issue. If you do this in a public repository, then the workflow file is visible. They can try to analyze that. And they see that you're now pulling in the title, and they can create a pull request or an issue inside your repository with a specific payload. For example, what happens when you send in a payload that has a double quote in here? Well, the shell will try to expand this and actually read what is in there. And now that echo test statement is actually being executed inside your workflow file. So as a remediation, you should always wrap those as environment variables. Those will always be strings. You cannot try to escape them. It will still be a string. So that's a huge security measure that you can take. And even if you use the command line or your shell, then use single quotes. That means that the string will not be interpreted and is now safer to use. I can recommend again reading more on this topic from those capture the flag events, where we've seen people who found a thing that they could misuse inside of a workflow, created that special payload, used the alleviated rights that they got from that payload to create a new pull request that automatically fixed the issue, closed that pull request automatically so that nobody else from the community could misuse it, and by that they won a bounty for the hack of that day. So really cool examples to see what are the attack vectors of your workflow file. All right, and with that, we can move over to the best practice that I said of forking actions. This used to be the default guidance, so it bears It helps if we can reiterate that, because this is now missing from all the common demonstrations that we see out into the community. Forking actions has, of course, some pros and some cons. The pros is that it is a lot more secure. You have a formal moment where you say, hey, I've checked all the source code that I see here. I'm okay with the risk that we're taking. We can now include this action inside of our own organization, fork it over, and from that moment on, our production organization can use the actions in our own actions organization. It also gives you a backup. The actions or repositories are open source, so the maintainer of the open source can always decide to do something with it. They might decide that they want to join the circus and leave everything untouched, for example. When you have forked it over, you can at least keep everything up to date on your end. They might say we want to collaborate with that, with an action with the rest of the community, and move the action over to an organization, for example. And now it has a different URL, and all of a sudden your workflows might not be working anymore. Apologies. It of course also has some negative associations. It gives you more maintenance work. You need to create a fork, you need to have an organization to handle all those forks in. And that might also give you a bit of a barrier for people to use new actions. But of course, in my opinion, that's now more secure, so that's a benefit for your organization as well. Now, if you're following best practices, then we need to make sure that we keep everything up to date. Now, how do you stay up to date? These actions are updated regularly, and you have created the fork. And how do you keep your forks up to date? Do you wait for a message from GitHub that says, hey, this one has been deprecated, for example, or there's a new version coming out? And how do you do that? Well, there's nothing on the marketplace currently where you can subscribe to updates for your own actions. You can use Dependable, that I'll show you later, but there's no notification system for that. So being a DevOps-minded person, I, of course, created something myself. There's a GitHub Twitter bot that you can follow to at least learn about new actions being deployed into the marketplace and new updates coming in as well. But this is a huge list now that I see daily flying by with all the updates from the community. We have 10,500 actions available. So there's lots of stuff happening, of course, during the day. So what more can you do? As I already said, we can use Dependable to keep everything up to date. We have two good options that I want to show you, and they all start with, whatever you do, review what the action is doing. Make that judgment, say this one is fine, that we can use it, and fork then your action over. So let's see how that works. When you pin a commit SHA, you can set up Dependable inside your organization by adding a Dependable configuration file in the .github folder, and Dependable supports the ecosystem of GitHub Actions. So this one scans on a daily interval my workflow directory, goes through all the YAML files in there, and then figures out what actions I'm using there. And if it sees that that there's a newer version available, it will send in a pull request for us. And this even works with version numbers, but also with those hashes. You can see that we're targeting here my own repository. You can see that this is already updating a fork that I have inside of my own actions organization. It says I want to bump that version from 003 to 005. But the incoming updates only specify the specific version update. On the conversation tab, it will try to show you release notes if the publisher of the action is using release notes, and it will show you the commits if it's a publicly versioned thing as well. But still, you're not really sure of all the code changes that you're pulling in. And as I said, start with reviewing what the action is actually doing. So if you pull in updates, you really want to know what those updates are as well. So for that, I have the second option, and that starts, of course, again with review what the action is doing, fork it over so you have it under control, and then I've got a good way to keep everything up to date, and you can still use Dependable for some of these things. So for keeping your forked action up to date, I've got an example here on my test repository that I have forked over. And the starting point is, of course, you fork it over, and then you wait for some engineer to figure out, hey, this fork has now been updated. The parent has new commits behind it, and we want to pull in those changes. There's now even a one-click button added to the UI that you can use to immediately pull in all those changes. But again, you would be pulling in those changes without looking at them and reviewing them first. So a better way is to have something automated around that. And currently there's nothing really available. You can do that at the repository level yourself, but I want to do this for all the forked actions inside of my organization. And that might be a large number depending on how active your users are using actions. So Of course, having a DevOps mindset again, I created a repository that you can fork over, and it will do the updates mostly automatic for you, but there is still a manual step giving you more control. This will even update itself if I push any updates into the fork updater. It contains a scheduled workflow that goes through all the actions that you have, all the forks of actions in your organization. And if it sees that there is an incoming update from the parent organization, it will create an issue for you. By using the issue, you can leverage the normal notification system side of GitHub. For example, immediately tag your security team that says, hey, you need to review this. And here we have an example of an issue inside the GitHub fork updater that says, hey, the parent repository of this fork has updates available. There's a link included here, which you can use to review the incoming changes, and that's an actual code-based link. So not only saying, hey, you're updating this specific version, but actual code changes coming in so that you can do the security assessment again of all those incoming changes. If you have reviewed it, and this is the manual part, of course, you need to look at what you're pulling in, and you said, well, okay, now that's okay to use. You can go back to the action, add a label. As I said, only people with maintenance access can add labels. And then a secondary workflow will be triggered that says, hey, I'm now updating all those incoming updates from the parent repository. And depending on how much time that takes is, of course, usually dependent on how large the repository is. And it will now update your fork. And when it's done, it will close the issue. Again, leveraging the normal notification system so people can follow along and they get notified that the issue has already been closed. So this is great for working in a team reviewing these upcoming updates. So as an overview of the pros of forking actions, you have a full backup and you have a formal way of taking control over the updates. And also the formal setup where you say, I've reviewed what is in this action repository and now I'm okay to use them inside of my organization. It also gives you a way to pull in all the updates centrally. So your security engineer is now reviewing that. So you might say, hey, I don't want to add a dependable setup in each and every repository that is using these actions. I'm doing that already centrally to the latest version. And now I want to set it up in my repository so we don't need to skip looking, that we don't need to look up the SHA hashes for each and every repository and each and every workflow. So it saves you a lot of maintenance work on that end as well. I've grouped all these actions in a blog post, so you can go to this link and find out about all of them. I think I have everything covered in there. And otherwise, please let me know if you have any additional questions on that. It's a large overview already of things that you need to be aware of. And with that, I think I've handled most of the things that I wanted to say. We've went over the repository and the security, and you also need to think about the runners that you're using to execute your workflow files. I've shown you a way to dive deeper into the actions and what they are doing for you. And I've mentioned the best practice of forking actions and making sure that all the forks are then still kept up to date. Some of the best practices that we've seen so far is make sure that you treat your secrets very carefully. If you take away anything from this session, then at least start reviewing the source code of the actions. Know what they're doing for you. Start now by pinning your actions to the commit SHA and then thinking about all the other security steps that I gave you. Never ever trust an incoming pull request from a public repository. We've seen the attack vectors for that. I went over forking the action repository and then linking your actual organization to only use local actions or the actions in your own actions org. I gave you the tip of using a test organization so you can set it up for your engineers to use. And I gave you a good way of keeping all the forked actions up to date. So with that, I think we're at the end of it. I hope you've enjoyed it so far and that we have some questions available to go over.
Thanks, Rob. To be honest, it was so comprehensive overview of all the best practices, and I think you already mentioned that you do have everything compiled in the one blog post. Yeah, that's nice. If you don't mind, just to share it later in the discussion as well for the people who just want to go through that checklist. Since you mentioned about the secrets, I was wondering, what is your take on using the secrets in the GitHub itself, like using the GitHub provided mechanism for the secret storing, vs by using the third-party wallets, like, I don't know, the HashiCorp wallet or the Azure Key Vault?
And the hard part is that you still need to have some way to authenticate against those third-party key vaults. So that's still an issue. If you're using that in your own private organization, you have private and internal repositories, it's less of an issue. I really don't like using them in a public repository to, for example, deploy into your cloud environment. We now have the newer option that has been shared with GitHub Universe that you can use OpenID Connect for limiting that and saying, hey, we have a security relation between my GitHub environment and my cloud environment. And you can specify there that this repository can only deploy to this application inside of my cloud environment. And that way is, of course, a lot safer to use. I need to make sure that I drop that link as well. That's a huge improvement that we have, at least connecting to the main cloud environments. But there are lots of deployments that you still do that need something like a key vault or HashiCorp vault. And that still starts with giving it a key. So the best option there is usually to have something set up specifically that at the beginning of the workflow execution, you request for a temporary connection, a temporary password, for example, that is only valid during the execution of the workflow. Pick that up somehow, but you probably still need a token for that, and that's the hard part. Use that short-lived token to do the deployment, and afterwards clean it up, revoke it immediately, and limit the blast radius of what everything can do, of course.
Yeah, that makes sense. Thanks. And we got the question, are there any best practices for actions that use Docker images inside?
Yeah, it's the same. Review what the action is doing, review the Docker image, find what is creating the Docker image, and check all the base layers in there and all the layers in between, of course. So really run the default scans that we have for scanning Docker images before you start using them. And maybe even think about taking them under control as well. Create your internal mirror, for example. Have a scan on top of that as well that executes every week or so to verify that even though it doesn't have any known vulnerabilities at the moment, it might have a new vulnerability next week, of course. So it's all extra security work that you need to think about and give that extra layer on top of it.
So do you think there is a need for the separate person who is taking care for the securing the GitHub environment, or it should be the part of the team's responsibility?
It's both. It depends a little bit on where you are on your journey. I think every engineer should be aware of the things that could happen. But usually you start by injecting somebody into the organization or the team that has that knowledge and mindset and start sharing what they already know and try to set up the best practices, tell everybody what they need to be aware of, listening to sessions like this of what could happen and how easy is it to inject something into a workflow, for example. So you need to know the patterns as well. So it's usually a mix of both. And depending on at least the customers that I join usually are at the beginning of the journey. So I still need to first scare them and from then start teaching of the things that they at least need to start thinking about, and then try to incorporate that as much as you can in the process, of course. Try to shift left any scans that you can do, at least start automatically scanning. We have a lot of tools available. Even scanning a Docker image can be done by Trivy in a workflow. It is already there, but you need to start using it.
Yeah, that makes sense. But Rob, thank you for your nice presentation, and it's so insightful. So I would suggest to our attendees and us to join to the discussion and keep continuing to answer on the questions there.
Yeah. So people will have gotten a Zoom link by now, right? And they can use that to join us in Zoom there.
Yeah, we are looking forward to see you.
All right, then I'll start moving there. See you there.